Hello learners, welcome to this program Education Online. I am teacher Akena Patrick Omoin, a teacher of physics. Today we are going to have our subtopic, which is image formed by plane mirror, under the main topic reflection in plane mirror. This is lesson for learners in senior 2. So dear learners, we are going to look at image formed by a plane mirror, where we shall look at the characteristics of this image. Before we look at the characteristics, we are going to consider various positions where we can place an object, then we determine the nature of the image form. So one, we are going to consider a point object. We are going to consider a point object. Point object. So when we talk about point object, we mean a small object that is placed close to the plane mirror. A small object placed close to the plane mirror. Close to the plane mirror. Dear learners, if we have a very small object that we are calling the point object, if we place it very close to the plane mirror, meaning it is near the plane mirror, what happens when the rays from the object falls on a plane mirror? So this is what happens, dear learners. If we have our plane mirror placed vertically, this is a plane mirror placed vertically. This is a plane mirror. We are placing it vertically. We make it to stand vertically. So this is the mirror. So dear learners, what we are going to do, we are going to put a point object to a position close to the plane mirror. So if we take this to be our point object, that is a small object which is placed close to the plane mirror. So what happens is that rays from this object will fall on the plane mirror. So if we take one ray from the object, so this is a ray from the object, and this ray falls on the plane mirror. A ray is always represented with a straight line with an arrow, and the arrow shows the direction of travel of the light ray. So when this ray falls on the object, this ray is going to be reflected. But from this same object, there can be so many rays that will be falling on this plane mirror. If we have also the second ray, still from the point object, which falls on the plane mirror. Now these rays are going to be reflected at the point of incidence according to the law of reflection. And the law of reflection, we said there are two laws. One states that the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. Then we say the angle of incidence is always equals to the angle of reflection. So this reflection is going to follow the law of reflection at the point of incidence. That is the point where the ray touches the mirror. So now this ray is going to be reflected in this direction. So this ray will be reflected in this direction. That is when it comes into contact with the plane mirror. Then the second ray still will also be reflected in another direction. So this ray is also reflected in that direction away from the mirror. So dear learners, when you look at these two rays are appearing to come from a certain point behind the mirror. When you are to look at the direction of the travel of the ray, it is appearing like the ray is coming from a certain point behind the mirror. So if we try to project this line, when we project it outward, then when we also project this. So dear learners, we shall see that these two rays that have been reflected from the mirror appears to be coming from a certain point behind the mirror, and we call this point I. So this point becomes the image of the point object, which is placed in front of this plane mirror. So this is the image. So now what happens is that the reflected rays appears to be coming from a certain point behind the mirror. So this is what happens, dear learners. When two rays from a point object is incident on a plane mirror, so these rays are going to be reflected according to the law of reflection. But once they are reflected, these rays will appear to be coming from a certain point behind the mirror. So now this point where the rays appear to be coming from is the image of that point object. And this, at the point of incidence, this reflection or the change in the direction of these rays or the bouncing back will follow the law of reflection. That is the two laws of reflection, which is the first law and the second law. Then, dear learners, let's also take a finite object. If we take a finite object, dear learners, what do we understand when we say finite object? So this is an object of a known size. It can be of a known height. It can be of at a known distance from the mirror. So this is an object of a known size. So when we are talking about the size, we know how big the object is and how high the object is. So now, dear learners, what happens when rays from an object of a known size is put in front of a plane mirror? We are still going to have our plane mirror being placed vertically. So this is a plane mirror placed vertically on a level floor. So we are going to place this mirror on a level floor. So this is a level ground. So now, dear learners, we are going to have an object of known size. So now, taking an object of known height, if this is the object, this object is of known height. So now what will happen is that rays from this object will fall on the plane mirror. So now if we take one ray from the object falling on this plane mirror, which is placed vertically, so this is a ray from the object. Then we can also have another ray still from this object falling on the same mirror. So this is another ray from the object falling on the mirror. So dear learners, when these two rays fall on this plane mirror, these two rays are going to be reflected according to the law of reflection, that is at the point of incidence. So now when these two rays hit the plane mirror, the first ray is going to be reflected in this direction. So this is the direction of the reflection of the first ray. Then this second ray is still going to be reflected according to the law of reflection at the point of incidence. That is the point where the ray touches the reflecting surface. So now this ray is going to be reflected in this direction. It will be reflected in this direction. Now, dear learners, when you are to look at the direction towards which the arrow is pointing, it appears like these two rays are coming from a certain point behind the mirror. So when you try to project these two rays, when you project this, then we also project the second ray. we shall see that these two rays that have been reflected from the mirror appears to be coming from a certain point behind the mirror, and this point we call it eye, or we say the image. So now when we place a finite object, that is an object of known size, in front of a plane mirror, so reflection will occur according to the law of reflection at the point of incidence. Then the reflected rays will appear to be coming from a certain point behind the mirror. So now we are going to say the reflected rays appears to be coming from a certain point, behind the mirror. So dear learners, looking at these two drawings, we shall find that whether it is a point object or it is a finite object, we shall find that after reflection, the rays will still appear to be coming from a point behind the mirror. When we use a point object, that is a small object placed close to the mirror, we shall find that after reflection, the rays will appear to be coming from a certain point behind the mirror. Then when we use finite object, that is an object of unknown size, we shall still find that after reflection, the rays will again appear to be coming from a certain point behind the mirror. So looking at this will lead us to the characteristics of the image formed by a plane mirror. So now let's look at the characteristics of image formed by a plane mirror, or the nature of the image formed by a plane mirror. The characteristics of image formed by a plane mirror. So now, dear learners, we are going to state our characteristics from the two illustrations that we had. Now we are going to use this. So when you are to look at this image is not formed by real intersection of rays. These rays do not meet, but they appear to be coming from a certain point here. So which means this image is formed by apparent intersection of rays. Or in other words, we say it is not formed on the screen. So an image that is not formed on the screen is called a visual image. So we say the image is visual. The image is visual. A visual image is an image that is not formed on the screen. Or in other words, we say it is an image formed by apparent intersection of rays. So now, dear learners, when you put a plane mirror before you, then you try to look through the plane mirror, you will find that the image that you see in the plane mirror appears to be behind the mirror. It does not appear to be exactly on the mirror. So why does it appear to be at a point behind the mirror? And when you put it, you try to touch behind the mirror, there's nothing. So it is because the rays just appear to be coming from a certain point behind the mirror. But in actual sense, it is not coming from that point. That's why we say it is visual, meaning it is not formed on the screen. Or in other words, we say it is formed by apparent intersection of rays. Still from our illustration, when this object is placed standing facing upward, so the image that is formed, this image is also facing upward. So now when the image is standing facing upward and the object is also facing upward, so we say the image is upright. The image is upright. Or we use the word erect. So the image is erect or upright, meaning it is facing upward. Still we can see that when you are in front of a plane mirror, so the image that appears seems to be at the same distance behind the mirror as the object in front of the mirror. That's why when you look at yourself on the plane mirror, when you try to move closer to the mirror, you'll find that the image also appears to be moving closer towards you, which means the object, the distance between the object and the mirror is the same as the distance between the mirror and the image. So we are going to say the image is at the same distance behind the mirror as the object in front of the mirror So when you are very far from the mirror, the image that is formed will also be far from the mirror. When you are very close to the mirror, then the image formed will also be close to the mirror. Dear learners, let's also state another characteristic of the image formed by a plane mirror. We say the image is also laterally inverted. The image is laterally inverted. So now, dear learners, what do we mean when we say the image is laterally inverted? So when you stand facing the mirror, you'll find that the image in the mirror will also be facing you. When you turn your back to the mirror, the image will also turn. You find that you see the image has also turned the back to you. So that is what we mean by lateral inversion, or we say it is laterally inverted. When you face the mirror, you find that the image is facing you. So that is what we call lateral inversion, or we say the image is laterally inverted. Then the image formed in a plane mirror is the same size as the object. The image is the same size as the object. Here we mean when you put a small object in front of a plane mirror, the image that will be formed in the mirror will also be very small. Then when you put a very big object in front of the plane mirror, then the image that will be formed will also be big. So that is what we say, that's why we say the image is the same size as the object. So dear learners, these are the characteristics of the image formed by a plane mirror. So after looking at this, dear learners, we can also use two plane mirrors. Now if we use two plane mirrors, how many images will be formed in those two plane mirrors? So that one leads us to look at images formed by two plane mirrors. And these plane mirrors must be inclined. They must be inclined, meaning they have to be put at certain angles called the angle of inclination. They are supposed to be inclined to each other. We can place the mirrors at various angles. We can place the two mirrors at 90 degrees. We put them at 60 degrees or any other angle. So let's look at images formed by two plane mirrors inclined to each other, inclined to each other. So dear learners, what we mean by inclining two mirrors is this. When we have, if this is a plane mirror, if we have a plane mirror, this is a plane mirror, we shall call this mirror 1. This is mirror 1. So now, dear learners, as we are using two plane mirrors, so we are going to incline these two plane mirrors at a certain angle. So if we also place another plane mirror, this is another plane mirror. We call it mirror 2. So we see that we have put these two plane mirrors at a certain angle. Let's call it theta. So now this is what is meant by inclining two plane mirrors to each other. We have put them at a certain angle. So now, dear learners, we can determine the number of images formed when these two plane mirrors are inclined to each other. For example, if we put an object at this point, that is between the two plane mirrors. So looking at the plane mirrors, a certain number of images will be formed in these two plane mirrors. So now, dear learners, we have a formula that we can use to determine the number of images formed when two plane mirrors are inclined to each other, meaning they are put at a certain angle. So now the formula says n is equals to 360 degrees divided by theta minus 1. Dear learners, this is a formula that we shall use to determine the number of images formed by two plane mirrors inclined to each other, meaning two plane mirrors put at a certain angle. So where n is the number of images, then theta is the angle of inclination. Theta is the angle of inclination, and 360 degrees is the total angle in a full circle, which means these two plane mirrors, we can place them at any angle. Angle ranges from 1 up to 360 degrees. 360 degrees is the total angle in a circular figure. So the angle that we are going to use will range from 0 to 360 degrees. So with this formula, we shall determine the number of images that will be formed by these plane mirrors, which is placed at certain angle to each other. So now, using this formula, dear learners, let's have an example on how we can determine the number of images formed by two plane mirrors placed at an angle to each other. Example: so now the example says, how many images are formed? How many images are formed? Images are formed when two mirrors are inclined at 60 degrees to each other. So dear learners, this is how a question can be set. How many images are formed when two plane mirrors are inclined at 60 degrees to each other? Meaning we are placing these two plane mirrors at an angle of 60 degrees. And that 60 degrees is the angle between the two plane mirrors. And we denote that angle with theta. So now, in our solution, we are going to find out what is given in the question and what the question wants us to get. So solution. Now, dear learners, reading through our question, we shall find that the angle at which the two plane mirrors are inclined is 60 degrees. So now, if we have one plane mirror This is one plane mirror. We call it M1, meaning mirror 1. Then we also have another plane mirror, and this is mirror 2. We use the word, the letter M2. So now these two plane mirrors are placed at an angle of 60 degrees to each other, and that 60 degrees is the angle of inclination, or the angle at which the plane mirrors are put. So now from the formula, from n is equals to 360 degrees divided by theta minus 1, where n is the number of images, 360 degrees is the total angle in a circular figure, then theta is the angle of inclination, then minus 1. So what is given in the question is the angle of inclination. So where the theta, we are going to substitute 60 degrees. So dear learners, we are going to have n is equal to 360 degrees divided by 60 degrees minus 1. So the 60 degrees is the angle of inclination, or the angle at which they are inclined. Let's have this portion. So now we are going to have n is equal to, dear learners, when you divide 360 degrees by 60 degrees, we are going to see that the 0 and the 0 will cancel. You have 36 divided by 6. And when you divide 36 by 6, you will get 6. So you have n is equal to 6 minus 1. And 6 minus 1 gives you 5. N is equal to 5 images. So which means if you have two plane mirrors placed at an angle of 60 degrees to each other, the number of images that will be formed in these two plane mirrors is equals to 5. So dear learners, this is how we determine the number of images for two plane mirrors inclined to each other. So after knowing this, dear learners, let us look at the uses of plane mirrors. Where do we use plane mirrors? How do we use plane mirrors? So we shall find that in our homes there are plane mirrors that we use. Some people, they use it for dressing. They use as dressing mirror. You find that when they are dressing, they go and stand in front of the plane mirror. So that is already one of the uses of a plane mirror. So let's look at uses of plane mirror. Uses of plane mirror. One, we say it is used as a dressing mirror. Used as a dressing mirror. We shall find that when people are dressing, they always go and stand in front of the mirror. So when you stand in front of the mirror, then you check your body, how you have dressed. So that is already the use of a plane mirror. Then two, we can say it is used in telescope. It is used in telescope. So telescope is one of the optical instruments. So we shall look at this under the topic lenses and optical instrument. So we also have, it is used in pointer instruments. Pointer instruments. So this is also one of the optical instruments that we shall look at when we come to the optical instruments or lenses. Then it is also used in periscope. Periscope. A periscope is also one of the optical instruments that changes the visual angle, or the angle at which we view an object. So dear learners, these are some of the uses of the plane mirrors. We shall look at these uses when we come to the optical instruments. So now, dear learners, you can be asked questions. You can be asked questions. A question can be, one, state the characteristics. State the characteristics of the image formed in a plane mirror. Formed in a plane mirror. Then two, you can be asked a question. Find the number of images formed. Find the number of images formed when formed by two plane mirrors. By two plane mirrors. Incline at 90 degrees to each other. And lastly, three, what are the uses? The uses of a plane mirror. So, dear learners, this is how questions can be said.